Good morning students, welcome my channel Bhuloks Mathematics. Last class I have already discussed about differential equation. Last class I have already discussed about order, degree. Today we discussing about the formation of differential equation. Write down formation of differential equation. How can you form a differential equation? Formation of differential equation means elimination of arbitrary constant. Write down formation of differential equation means elimination of arbitrary constant. Give an example. Suppose y is equal to c1 sin x plus c2 cos x. So form a differential equation. There are two arbitrary constants. One is c1, another is c2. There are two arbitrary constants. So we have to eliminate these two arbitrary constants. So in order to eliminate two arbitrary constants, we have to differentiating it in two times. So write down dy dx, derivative of c1 constant that is coming outside, derivative of sin x that is cos x. c2 is a constant that is coming outside, derivative of cos x that is minus sin x. Okay, so now d square y dx square, this is known as y2. So d dx of y1 means d dx of c1 cos x minus c2 sin x. c1 is a constant that is coming outside, derivative of cos x that is minus sin x, minus c2 derivative of sin x that is cos x. So taking minus common, we get c1 sin x plus c2 cos x. So this is nothing but y. This is nothing but y. So minus y. So the differential equation is given by y2 plus y is equal to 0. So this is the differential equation. It is its solution. The corresponding differential equation is जेतेटा आर्बिट्रारी कांस्टेंट थिबो सेते थरो डेरिवेटिव करिया को पड़िबो. Suppose an equation contain n arbitrary constant. In order to eliminate n arbitrary constant, we have to differentiating it n times. Okay, so write down the NB. Suppose an equation contain n arbitrary constant. In order to remove n arbitrary constant, we have to differentiate n times Okay, so this is very important note you have to remember. Suppose an equation contain n arbitrary constant. In order to remove n arbitrary constant, we have to differentiate it n times. So the relationship between the differential coefficient, dependent variable and independent variable. This is the corresponding differential equation. Suppose solution is given, our aim is to find out its differential equation. Okay, so write down another example. Another example you have to write down. Example, y is equal to a e to the power x plus b e to the power minus x. Form the differential equation. Question, form the differential equation. So here there are two arbitrary constants. A and b are two arbitrary constants. In order to remove two arbitrary constants, we have to differentiate it into two times. So write down differentiating on both sides with respect to x. So dy dx is equal to, a is a constant that will be coming outside, derivative of e to the power x, that is e to the power x. B is a constant that will be coming outside, derivative of e to the power minus x, that is minus e to the power minus x. So next d square y dx square. So that is d dx of dy dx. This is the definition. So this can be written as d dx of dy dx value is here a e to the power x minus b e to the power minus x. So a is a constant that is coming outside. Again derivative of e to the power x, that is e to the power x, minus b is a constant that is coming outside. Derivative of e to the power minus x, that is minus e to the power minus x. Again we get a, it is e to the power x, plus b e to the power minus x. So this is nothing but y. So this is nothing but y. So the corresponding differential equation is d square y dx square is equal to y. So this is the answer of this question. Number of arbitrary constant is 2. So in order to remove two arbitrary constant, we have to differentiating it two times. So this is the answer of this question. Write down another question. Form the differential equation. Question number 3. Y is equal to a sin inverse x plus b cos inverse x. Question is coming like this. Form the differential equation. Form the differential equation. So here there are two arbitrary constants. One is small a, another is small b. So in order to remove two arbitrary constants, we have to differentiating it in two times. So first of all differentiating it, we get dy dx समान है d dx of a sin inverse x plus b cos inverse x. A is a constant that will be coming outside. Derivative of sin inverse x 1 upon 1 minus x square. B is a constant that will be coming outside. Derivative of cos inverse x, that is minus 1 upon 1 minus x square root over. So here we get LCM a minus b divided by 1 minus x square. So cross multiplying here we get 1 minus x square into dy dx is equal to a minus b. Very special problems. Now squaring on both sides. Write down squaring on both sides. Squaring on both sides. Squaring on both sides. We get 1 minus x square into dy dx whole square is equal to a minus b whole square. Our aim is to remove the arbitrary constants. Thare differentiating heichi, out thare differentiating karibaku padibo. Like again differentiating on both sides with respect to again x. Again differentiating on both sides with respect to x, we get d dx of 1 minus x square into dy dx whole square is equal to, so d dx of a minus b whole square. Let us take, it is u and it is v. Applying the product formula. First derivative of second, write down 1 minus x square u derivative of v d dx of dy dx whole square u derivative of v plus v dy dx whole square into d dx of 1 minus x square. Here it is a constant. The derivative of constant is 0. Okay. So now we get 1 minus x square. The derivative of this 2 into dy dx into d dx of dy dx. Applying the chain rule. So here plus dy dx whole square. Derivative of 1 is constant. 0. Derivative of x square, that is minus 2x, is equal to 0. Okay. So now you see here. 1 minus x square, 1 minus x square into 2 dy dx. Here it is d dx of dy dx, that is d square y dx square plus dy dx whole square, it is minus 2x is equal to 0. So now taking common 2 dy dx, 2 dy dx taking common, we get 1 minus x square. Here it is y2, this is y2. Here we get minus x, here it is y1 is equal to 0. So 2 dy dx divided there. So we get 1 minus x square y2 minus x y1 is equal to 0. So this is the answer of this question. Now let us take another example. Find the, write down question, find the differential equation corresponding to family of ellipse whose center zero zero, axis horizontal. Axis horizontal. Okay, find the differential equation of family of ellipse whose center 0 0, axis horizontal. But first of all we have to know about what is the equation of the ellipse center 0 0, that is taught in 11th class. So now write down the equation of ellipse. Answer Equation of ellipse. Equation of ellipse. Center 0, 0. And axis along x-axis is given by s square by a square plus y square by b square. It is 1. X square by a square plus y square by b square is equal to 1. So here there are two arbitrary constants. One is a square, another is b square. Differentiating on both sides with respect to x. So d dx of s square by a square plus d dx of y square by b square is equal to d dx of 1. 1 by a square is a constant that is coming outside. Derivative of x square, that is 2x. 1 by b square is a constant, so that is coming outside. So y square derivative 2y into dy dx. Here the derivative of constant is 0. So now we get 1 by b square into 2y dy dx is equal to minus 2x by a square. So b square will be divided here, multiplied there. 2 is also 2 to cancel. So y dy dx is equal to minus b square by a square into x. Okay. So now this x will be divided here. We get this x will be divided here. We get here it is y, here it is y1 by x is equal to minus b square by a square. Now differentiating on both sides with respect to x. So d dx of y1 divided by x is equal to minus d dx of b square by a square. So this is the total constant. Derivative is 0. So apply the division formula. Division formula u by v x d dx of y into y1 minus y into y1 into d dx of x. Here it is 0 divided by x square. V derivative of u minus u derivative of v divided by v square. So now we are applying the product formula. Here x product formula y d dx of y1 plus y1 d dx of y minus y into y1 derivative of x is 1. S square multiplied there, we get it is 0. So now d dx of y1, that is y2. So x y into y2 plus here it is y1 d dx of y is equal to, this is also y1 minus y into y1 is equal to 0. So y1 into y1, that is y1 square. So we get last x y into y2, here it is y1 square minus y into y1 is equal to 0. So this is the answer of this question. Family of ellipse whose center is origin and axis is along horizontal. First of all, you have to form the equation. Then there are two arbitrary constants. One is a square, another is b square. In order to remove two arbitrary constant, we have to differentiating it in 2 times. Okay. So this is all about today's class. Thank you to all for watching my videos. If you like my classes, please subscribe my channel, likes my channel and